So, hello everyone. Welcome to today's masterclass, Smart Cities and Climate Change, Enhancing Livability in the Age of Urban Intelligence. Thank you for joining us today. If you ever wondered how to enhance livability in the age of urban intelligence while facing the challenges posed by climate change, this session will equip you with practical insights and strategies to create smarter and more sustainable cities. I'm Thaisa Figueroa, Institutional Engagement Manager here at Ziggurat. And for those who may not know us, Ziggurat is an online institution with over 20 years of experience in e-learning. We provide master's and postgraduate courses in architecture, engineering, and tech management. And we are proud of our diverse and vibrant community of over 20,000 students from 120 different countries. So today's masterclass aligns closely with our Masters in Global Smart City Management, where we equip professionals with strategic and practical skills to lead transformative smart city projects. So our program is structured in three essential blocks, each focused on critical areas to effectively manage and drive smart city initiatives. So the block one is strategic perspectives, business opportunities, and citizen engagement. Focus on urban strategy, financing smart city projects, and fostering citizen participation through open data and collaborative approach. The Block 2, New Technologies and Tools, delves into the latest innovations in connectivity, data analytics, AI, machine learning, and blockchain, empowering the students to leverage these technologies to advance smart city solutions. And the Block 3, Sustainability, Resilience, and Urban Challenges, addresses urban planning, the circular economy, waste management, and resilience to external stresses, including energy transitions on low carbon strategies. And also, today's masterclass is closely aligned with the themes of these blocks. So this program combines an interdisciplinary approach with a focus on real-world application, equipping participants to lead innovative smart city projects. A key highlight is the hands-on development of a final master project, where students design practical smart city solutions guided by expert mentors. Our program fosters a global vision, emphasizing smart citizenship, mobility, and sustainability, while providing access to an international network of professionals and industry leaders. So with personalized mentoring, alignment to global standards like the UN New Urban Agenda, and a focus on cutting-edge technologies, this holistic program ensures graduates are ready to drive impactful, transformative change in urban environments. So if you want to know more, feel free to scan the QR code to explore the program. And if you are interested, fill out the form and our team will get in touch with you. Okay. So now I'm pleased to introduce our speaker for today, Guilherme Corral. He is an architect and urban design lead at MCORM Architecture and Urban Design. Is lecturer in the Ziggurat Global Masters in Smart City Management, which has mentored final master projects about well-being and livability in the 21st century smart cities. And Guilherme is also a Ziggurat alumni of the same program, graduating in 2021. So before I pass you the floor, Guile, I would like to comment to our attendants that if you have any questions during the session, please leave your questions in the chat, and we will address them during the Q&A at the end of the session, okay? So, Guile, thank you so much. And the floor is all yours now. Thank you.
Thanks very much, Thaisa. So before starting my presentation, I will share my screen. Okay, share. Yeah, we are there. So good afternoon, and I also say good morning because I guess this masterclass is global, so we have people in many time zones. Thanks very much for joining. Thanks very much, Thaisa and Sigurat, for giving me the opportunity of sharing or being involved in this masterclass with all of you and covering topics that I address in my professional career, but they are also addressed, as you said, Thaisa, they are fully aligned with the topics and items that the Sigurat Global Masters in Smart City Management addresses throughout its program. In this case, and coherently with me, as I am an architect and urban designer, we are gonna concentrate on the physical dimension of the city and of its special condition, and relating the urban challenges that we are currently facing with climate change, as climate change is a cross-cutting affair, a cross-cutting challenge that many disciplines are facing in the city. Notwithstanding this, I will mention throughout the masterclass and in the conclusion specific technologies, consolidated and emerging, that can be applicable to these challenges, to tackle these challenges and have, let's say, better solutions to succeed in these matters. Um, this is the approach of the course, actually, which is that technologies are always a tool, they are not a means, and therefore the tools are to face these urban challenges. Before getting into the contents, just to elaborate on my profile so everyone can know me, I am Guillermo Corral. As Taisa said, I am architect and urban designer. I was alumni of Sigurat in its 2020 edition, which is one of the most challenges because it was in the pure COVID pandemic. Since then, I had the chance to join as a lecturer. So it's already 3 years being lecturer in Sigurat in the built environment module, particularly, and also mentoring final master projects that I will be able to give examples of those during this masterclass, which I'm very, very happy and proud of. I have circa 10 years of professional experience in architecture, urban design, and consulting in strategic urban development. And currently, my main occupation, beyond lecturing in Sigurat, is being the urban design lead of an Irish architectural and urban design firm, Encorn, that is dedicated to private master planning, large scale residential, and also urban design strategies and public realm work for the public sector. So what are we gonna cover today? It's I'm gonna be speaking for around 30 minutes, as discussed with Thaisa and announced previously. There will be a Q&A section there in which, according to the topics covered, you'll be able to ask questions after this kind of approximately half an hour. So we're gonna identify main urban challenges related to climate change. Of course, you might think of more, and I will really welcome that you can share these or query these after. The second point, according to this framework, will be introductions and definitions to the concepts of this masterclass. So, as we are talking about livability, it's important to identify what really urban livability is, because it can be a very subjective topic and it can have really many approaches and theoretical discussions. So we are going to frame the topic in that regard and try to be pragmatic and see how can livability be addressed and enhanced. And of course, we're gonna explore what a urban habitat is, because that's our ecosystem, is our built environment, is where all of us, being more rural or more urban, live in. Number three, it's key resources for, or key sources, sorry, for urban livability. So I'm going to talk about 4 sources. 2 of them are more related to nature, and 2 of them are more related to man-made systems. Then number 4 is academic case studies for practical implementation. As Thaisa said, the conclusion of this Masters in Smart City Management is a final master project that, while being an academic piece of work, aims to have a practical implementation, and we already have cases of those. I'm lucky today. I have the honor to be able to share two examples of different editions and different topics that I've had the chance to supervise, and then I'll share some conclusions with you according to these topics. So, urban challenges. This is gonna be very quick and very illustrative. In many places of the world, we are already suffering for summer events, heat wave events, in which we are experimenting the living at 50 degrees or 122 grade Fahrenheit. We have this phenomenon of heat islands that doesn't happen magically, but happens through, let's say, hard urban design that doesn't integrate biodiversity, permeable spaces, nature, vegetation, etc., within the downtown of the cities, which are mostly surrounded by industrial lands. So we have a multiplied effects due to industrial lands and downtown, both of them hard landscaped, as I say, very scarce vegetation, and therefore we experiment these heat islands that within a city you can see in the left hand side the map of Barcelona. The heat islands vary or range between different areas because the urban design of the city it's different. So we can say that urban design impact on these phenomenons. And as you can see in the heat scale here in Barcelona, we can range 4 degrees between some areas through others because, as I said, the built environment is impacting on that, and it's definitely impacting on our lives depending on where we live. We do have, and this has been much more significant in the last years in the full Mediterranean, and particularly and sadly in the Valencian coast. We've had this, as I say, throughout the Mediterranean, also in Italy, but particularly in Valencia last end of October. So basically, we don't know how to manage water, or we try to put barriers to nature, and nature doesn't have barriers. So at the end, urban environments, housing areas, people definitely are severely impacted by these climate change phenomena, by these let's say climatic hazards that are increasing in intensity. It's also important to consider, I was showing an image within an urban context. Now I'm showing an image within a rural area or an agrarian area, which is also, of course, exposed to this kind of phenomenon. And I know we're talking about cities, but at the end of the day, we all consume food. We all need food. And agrarian land is key for urban living because it's sourcing us by food and other raw materials, and of course gets this impact of climate change that is mostly caused by industrial activity and cities. A cause of this is that cities are invading natural ecosystems and biodiversity. Also, the pandemic was a consequence of this human behavior. So if you see the illustration in the left-hand side, there is a concept that is called zoonosis, which is that we not just put barriers to green species, we also impact animal, insects, ecosystems that happen in natural habitats. And therefore, we have, let's say, we have a higher chance of getting diseases from animals, etc., because we impact in the ecological chains, in the ecological systems, and therefore we get more exposed to those, while nature is a let's say is a great barrier for those kind of virus and bacteria, etc., that if we would maintain, or if we would contain that biodiversity, and we would contain that urban sprawl that indicatively you can see in the right hand image, we would prevent for not only pure climate change impacts, but also this kind of health impacts. And I just want to mention before getting into the next slide that it's not just about building, it's also about infrastructure, because what the right-hand side image wants to tell is that nature gets constrained. So it's not just to have greening all over the place with nonsense, it's also to achieve continuity between the different biodiversity corridors. If we interrupt those biodiversity corridors, at the end, regardless retaining some natural species, we are impacting in, as I said, animals, insects, etc., because we are interrupting their life, basically their habitats. More events related to climate change. This is flooding in the outskirts of Barcelona, in the metropolitan area of Barcelona. So in addition to flooding, we have pollution, again, caused by different elements. In this case, it can be industries, it can be heating and cooling systems in houses. It can be, of course, polluting mobility, both vehicle transport and urban good distribution. We also have, and this kind of, this at the beginning, it can be more related to the social aspect of the city. But at the end of the day, as I said, urban environment condition our lives, and social inequality in this case is reflecting spatial inequality, which means that some people are more privileged than others just because of living in a place. And that place at the same time can be more or less resilient to climate change and to extreme climate events. And in this photograph, you can see that, of course, the right-hand side of the image is going to be much more exposed to that severe impacts of climate than the left-hand side, because um, houses have more outdoor space, they have more permeable areas. So not all the places in a city are same resilient or have the same impact to climate change, regardless being in the same location. Having said that, so we've framed the problem, and having said that, I would like to enter in what a human habitat is. And before going into that, let's say it's important to address what a habitat itself is. So the term habitat traditionally refers to the natural environment in which a particular species, we were talking about animals, insects, proper vegetation species, live and thrive. It includes all the physical and biological factors that a species needs to survive, such as food, water, and shelter. Of course, this habitat in general, we are here yet concentrating on the natural habitat. So all that is man-made is excluded from this natural habitat. But now we come in the human action. So in the context of cities or any anthropocized territory space, can be of more rural or urban aspect, the concept of habitat can be expanded to encompass the built environment where humans reside. And attention to this. This urban habitat is designed to meet the needs of the human occupants. So in this case, humans, people get protagonism. But it says, while ideally maintaining a balance with the local ecosystem. And that's what we are gonna explore in this masterclass. So I repeat, the human habitat, the built environment, is ideally designed to meet the needs of people, sometimes not of everyone, but from a theoretical perspective, it's designed to meet the needs of its human occupants, people, while ideally maintaining a balance with the local ecosystem. So again, it's balancing our needs with existing nature needs. And those needs and those ecosystems are already in place while we were not. If I continue in the concept of a human habitat, we can say that a city itself is an ecosystem, and we have an overlay of different ecosystems. So we have the global ecosystem, we have the natural ecosystem, so nature can wrap us. Then we have the built environment. The built environment always always happens within a natural environment. It's true that a natural environment can be hardly compromised because of the action of the built environment and its activities. Then within that, we have local economies, we have communities, we have lifestyle, and at the end, we have us. So all of those are ecosystems from the globality to the people, and that is what composes a city, an urban environment, a built environment. This infography, I have to say, is from a really good book that I recommend, which is Shaping Neighborhoods for Local Sustainability, so for local health and global sustainability. And as I said, it reads the complexity of cities, both considering what happens in the local scale, in the activities of the city, in the built environment, and in the wider context, which is the natural environment. Now we go to liveability in smart cities. Liveability as a concept is something that has been greatly discussed, and it's particularly in the last years, because we are having rankings of what are the smarter cities, what are the happiest cities, in which cities the quality of life is better, etc., etc. So in general, liveability describes the qualities of a community or city that contribute to the well-being and quality of life of its residents. It encompasses a variety of factors, and it is key to select and define them as measurable indicators for a successful liveability framework. So, from a first approach, liveability can be seen as a subjective concept. But fortunately, in this second generation of definitions of a smart city, smart cities are not just related to gadgets, technology, etc., applied as a means, as a final objective. But now, in the second generation of smart cities, we are seeing that the focus is concentrating on how the city delivers well-being. And therefore, we can say that livability is connected to the performance of that city. And we are getting into the idea of key performance indicators for that city, indicators that are related to the well-being and quality of life. And of course, as I was saying in my last sentence, these indicators need to be measurable, because if not, discussions about livability are not useful. And we cannot compare cities among others if we don't establish global indicators and global methodologies using, of course, technology to compare those and try to enhance from those frameworks, reading the city, analyzing the city, try to enhance its current conditions. So that's an approach to what livability is. As I said, livability is a concept that has been discussed particularly in the last years, but also in the last decade. So it's a I would say a 20th century concept. We can also retrieve what the Maslow pyramid says about the key needs of every human, etc. But focusing on cities, I can highlight the program United for Sustainable and Smart Cities of the United Nations, which is aligned with the new urban agenda. Again, a global framework. This is a global masterclass, so you'll see some local examples of Spain, which is my country of precedence, but we're trying to establish global frameworks. It's the same that we do in the masters, and a global framework is this tool, as I said, from the United Nations, that establishes a methodology to create or to analyze a performance of every city in the world. At the end, if we get deep in that discussion, we need to establish domains. Those domains, in this case, are society, economy, and environment. And from those domains, the methodology establishes different key performance indicators, as you can see in this illustration. But still, we are not talking about particular neighborhoods and communities. We are talking about cities overall. If we go, so we were talking about domains, as I say, society, economy, and environment, but going a step behind, we can talk about key sources. So we go still to a more strategic level, okay, which is key sources. There are more, of course, but I'm just going to talk about, just to give an example, this methodology could be extended to more sources as identified, but I'm going to talk about water. I'm gonna talk about trees or any source of vegetation within the city. I'm going to talk about energy, and I'm going to talk about housing. So first of all, in terms of water, beyond its management, what concerns cities, and particularly in the last years, is how do we manage surface water? How is a city resilient to heavy rain events, unexpected rain events, varying meteorology, and then, of course, as a consequence, heavy flooding, etc. As you can see in this diagram, it's self-explanatory, okay? If we are in a, let's say, permeable area, so an area that is soil, there's no hard paving, is fully or almost fully permeable, there is a curve in the surface water that has a peak, of course, but is a moderate peak, it's a low peak, and then it goes down. However, if the same event happens in an unpermeable environment, which is any city, streets without vegetation or streets with very small amount of vegetation or vegetated areas, permeable areas, landscaping, very few areas of that, the curve is really exponential. It goes really high, and then we have these flooding events, and then it goes down in a, let's say, a certain time frame. But the city has the problem in that certain time frame because normally the city is designed to face this amount or this amount, but not to face these water flows. This is something that is extraordinary, and therefore normally urban design, civil engineering in the city is not prepared to this flow of surface water management. If we go further, we are starting to look at projects like this. This is an example of a linear park that's been designed by Battle-Leroy architects in Barcelona, in Catalonia. And as you can see, there is an integration of how do we manage water in different ways. So basically, the section is not yet, so the urban design is not just happening above ground, but also below ground. And what is happening with water in almost dry events, but also in flooding events. And this section of park is much more prepared than any street in any city because it is considering that surface water management in higher flows. These projects are introducing the concepts of SUDS, which is sustainable urban drainage systems. Is different systems to manage and reuse water in a sustainable way, meaning that we don't impact on existing water flows, and we also are able to resist to heavy rain events or similar. And in this case, we are also putting the opportunity or shaping the opportunity to not only manage water, but also reuse water for other purposes in certain filtration schemes, water circularity, etc. As you can see in this diagram, we have different features of sustainable urban drainage systems. Of course, some systems are more natural, others are more urban. In some cases, we achieve a 100% of permeability, in others we don't. But in any case, we are reducing the impermeable surfaces in the city, and we are making cities more resilient. And at the same time, as I said before, we are shaping opportunities to reuse water. We have, let's say, the more urban solution is permeable paving. We can have permeable paving in parking, and also we can have some permeable paving compatible with traffic. And then, of course, we go to bioswales, water retention areas, filtration areas. Also, those allow for natural habitats. We can have animals, insects, of course, vegetation species that are used to more wet areas. And then, of course, we can integrate in a better way existing water flows. This is very connected. So as you see, it's all of this is cross-cutting, because we cannot isolate water when we are talking about habitats that include built and natural environments. So we go from water to trees, but we are manipulating these two sources to make cities more resilient. So if we go to the next source, which is tree, this is something that is greatly assumed by the architecture, engineering, and construction industry, but we still see many hard landscaped areas without trees, without vegetation, without nature. So it's important to repeat that trees can cause a great impact on mitigating heat waves and, of course, flooding, rain events, etc. But in this case, I'm gonna concentrate in the first challenge, which is heat waves. So as you can see, the temperature of the different surfaces in the street can vary greatly just by introducing trees. And then I also want to introduce, so we had the first concept of suits, and now I'm going to introduce the concept of biodiversity net gain. As I said before, every city happened, or every development happened in a natural environment. Then this natural environment evolved into a built environment, but the point of origin is a natural environment. So we have our biodiversity metric, which is what we originally have in any development, being greenfield, brownfield, or a retrofitting of an existing urban fabric. We do have a biodiversity metric. It can be high, it can be low, but we have that asset. Then we do our biodiversity net gain plan, which means that we need to retain as much biodiversity as possible. And even in some occasions, it's possible to regenerate an existing ecosystem, and regenerate means improving this metric. And finally, our project delivers a habitat value, which is that built environment, but retaining or even increasing that biodiversity metric by our BNG plan. So that biodiversity net gain has three scenarios, which are obvious. We have an environment that has whatever natural assets originally. We do our developments. We don't consider any of that, and we have a net loss. So basically, our impact is totally negative, because we are not considering any of the existing ecosystems. I repeat, it's not just about nature, it's also about all kind of species, animals, insects, etc. We have our second scenario, in which we are retaining. So we are not impacting negatively, but we are not generating a positive aspect, because we are not regenerating. So we have a no net loss. This can, if we compare to the first example, this can be positive, because at least we are keeping the situation as it is. But what we are looking at in urban design, regardless the climate, regardless the location, regardless the conditions all over the world, is to have a net gain, which means that the development delivers a built environment, but this built environment is also, due to its integration, as I said before, we can include different, let's say, tools that are, so for example, sustainable urban drainage systems. We can retain biodiversity corridors and other features, green roofs, etc., we can achieve a net gain, which means that we are delivering something that is better of what we found. On those key sources, now we jump into energy. And this diagram is meaning that here we are not going to just talk about energy demand, but we also are going to talk about energy production and potential emerging business models. I want to exemplify this source with what Helsinki has done. And here we enter into digital applications, digital technology applications. I consider that sustainable urban drainage systems, that's also technology. It's not just digital, it's physical, but it's a technology that we can use very easily. We can digitalize that sustainable urban drainage systems, of course, because we can put an Internet of Things, we can put any sensors, and we can monitor what's happening in that in terms of water flow, levels of humidity, etc. But now we come in fully digital tools, as I say, such as the Energy and Climate Atlas of Helsinki that I recommend you all to visit. This atlas has mapped in 3D energy data of each building, solar energy potential of each building in its area, heat demand of each building, and geoenergy, because in this case, this is particularly relevant as Helsinki in its underground has certain areas of geoenergy potential. With these kind of tools, we are able to manage city energy demand in a more smarter way. And I won't detain on this because it's very obvious. We can take data-driven decisions based on what is the current demand, what is the saving demand that a certain building or a certain complex can achieve, or a certain area can achieve by doing X, Y, or Z retrofit in action. We can also see how what is the volume of CO2 emissions. We can see what refurbishments are happening in the city, and we can also introduce the climate change factor based on 2030, 2040, or 2050. But beyond that, as I was saying before, there's cross-cutting impacts, positive impacts in this case, by using technology. If we could overlay a social map over this atlas, we could be able, for example, to prioritize retrofitting grants, meaning that if I am a smart city manager and if I have a budget in my, let's say, in my management, in my competence, and that budget is to transfer grants to residential communities or other, or retail, or whatever use, but particularly residential. And I can overlay what is the, let's say, lower performance or higher heating demand versus what is the level of income in a city. If I could overlay both and combine the lower income with the higher demand, I could be able to be very smart in prioritizing my money, because I understand budget is finite, and this would be a very smart way of deciding where grants are going to. This is just an example. I also want to introduce the concept of cities as energy prosumers, because we see cities and buildings as consumers of energy, but we can change our mindset and we can change how cities behave by establishing different ways of producing energy in the local point of consumption. And I'm sure that many of you know that we could put solar panels if in a roof of a house. Even we could put any other means of renewable energy production in any building, and the building can be zero, can have a zero demand because it's producing the same energy that requires, and it can even be a positive building because it can generate, for example, buildings with very, let's say, very elevated roof areas, very big, let's say, footprints that can have, as it was saying in the atlas, you can see here solar energy potential. So we can apply that solar energy potential to this approach, and we can have positive balance buildings. So as you can see in this flowchart, the traditional power plant and renewable energy are all feeding energy. So they are all feeding the different, or nuclear power plants, to the control center, and the different consumers, public facilities, cities, vehicles, etc. But we can have a smarter environment and smarter cities if energy was produced locally. And this is just changing the mindset of a building from a consumer to a prosumer, or from a building that is consuming energy to a building that is producing energy and that is a power plant, can be conceived as a power plant. This is something that is created with artificial intelligence. This is how we can imagine a smart city, but at the end, it's something more aesthetic, if you enable me to say that, and more integrated into a realistic environment. So it's much more feasible that these futuristic images, this is something that is already happening. This is, for example, a building in Barcelona. It's not something that you can just do in the roof. It's something that you can do, for example, in this south-oriented facade of this 4-story building. So now the final source is housing. So beyond the smart building or smart home, unfortunately, housing is not a key topic in the overall smart city discussions. And actually, a great example of this is that the ISO standard for smart cities just sets two non-strategic indicators for housing. There are many indicators in this ISO, and there's just two non-strategic indicators for housing. One is the percentage of smart energy meters and the percentage of smart water meters in any house. And this, of course, is not tackling strategically the housing challenge that we are facing all over the world. If you look for any word cloud of what a smart city is or what are the main topics of smart cities, you don't see housing in the bigger, let's say, words that are repeated. And I just took one, but you can take many, and you don't see even, you can see many, maybe you can see population, citizen, communities, civil, intelligent is more in smaller text, inhabitants really small, household here, but there's no housing protagonism at all. And as I say, it's just one, but you can get many, and you won't see housing. If maybe you see housing in very small, but you won't see housing in a big size. Again, this is just from the European Union. There might be other paradigms in other locations in the globe, but overall in Europe, the rise of housing prices is notable, and it's overall in the, you can see the European average is almost 50%. So smart cities started to be a topic, I'd say 5 years ago of this, so 2010. In the second generation of smart cities, of the concept, discussions, etc., we've started to talk about housing, and we are now getting the consequence of housing not being a topic that has had the protagonism that was deserved. Now we are having this situation, and of course, my proposal is to put housing in one of the main topics in the smart city discussion. This is a very illustrative image of what happened in COVID-19. So many buildings had no private outdoor amenity, and by a very simple solution, simple but clever solution, all these dwellings could have a small but have some private outdoor amenity, because COVID meant staying more at home, and this was the case of Stalin. Private. This is a scheme where they installed private terraces at the houses. It's also a reflection that we realize that we stay almost 70% of our time at home, and again, houses are not in the smart city discussion. We can have small density, but again, small density suburban, very poor open space, no relationship. You see that we are looking at different means of transformation of this space in low density. It can be medium density, again, an effort for community. This is Marmalade Lane, it's a co-housing scheme in which the different units relate together. This is, of course, very smart, because it's not just about technology, as I said, it's about establishing the correct relationships and opportunities for people to enhance their well-being and enjoy in the community where they live. And of course, it can be in higher density. This is, by the way, the highest timber frame residential building in Catalonia so far. Now I'm going to go very fast to the case study, so we have a bit of room for discussion. I'm just gonna talk about two case studies that I've had the chance to mentor in the Smart City course, and this is also the purpose is for you to see samples of what we can do or what we do in the masters. So this one was presented in the Smart City Expo World Congress in Barcelona, November 2023. So it's in the 2022 edition. It was elaborated by Mohammad Hamal, Nasir Al Hassan Ahmad, and Light Mukasatas. And it's about BIM and GIS integration for smart city planning, a case study for Masdar City. So this is a neighborhood in Abu Dhabi, and basically the conclusion of this is that as professionals, we faced static development plans. So just a PDF that says, where can we build, where can we not build, what is the land use, what is the zoning. However, this team prepared a smart map that can be used as a dynamic development plan that both establishes what is the zoning, so it's a more static layer, but at the same time you can monitor how are developments going. And of course, you can also manage all developments, not just in design and construction, but also through its whole life cycle. The model enables you to integrate building information modeling of the different pieces. Of course, you have GIS because you do have geographical information of planning. You have geographical information of the context. So joining both together, they created this platform that, as I say, is called Smart Map. And the name is because it can be dynamic, and also you can establish what is the degree of detail of the different modeling inputs that happen in the platform, meaning that some professionals might be interested in detailed modeling, building information modeling, all the details of all the buildings, while other practitioners, namely urban planners, might just be interested on this volumetry, integration of infrastructure. Of course, infrastructure, civil engineering schemes can also be modeled, as this part can be integrated in the full map. And as I say, it's dynamic, so it can evolve about time, and it, let's say, supersedes that paradigm of a county development plan or a local development plan needing to be renewed each 7 years, 10 years, 15 years, while this is endless and can be established for time and time. And as I say, the principles are a centralized smart map, combining basically BIM data and GIS data. The next steps for these approaches are digital twins, which are the integration of a city model, geospecialized data, preferably open, different registers, that is in a big data scheme. And then you have data coming from sensors, simulations, plans, etc. You plan the full life cycle before building or giving permission, for example, for a planning scheme. You can have simulated impacts, so you can have scenario planning before changes are made, how this will behave, etc. first digitally before having that in reality and then not working. And this leads to better understanding, better decisions, better city and quality of life. This is a methodology that Helsinki established, for example, for the Energy and Climate Atlas and their emerging digital twin. And then we can have, as I say, the Helsinki is working in its digital twin in the overall city in different layers, but also particularly getting into more detail in a particular neighborhood, using it as a pilot project. And then Barcelona, where Segurat is based, is also developing from this year onwards its own digital twin. Case study 2 goes from pure technology, we were talking about BIM and GIS, to a neighborhood liveability framework. So this liveability framework aims to enhance the magic of the neighborhood by establishing indicators and identifying if a neighborhood is performing well for the purpose of well-being and quality of life. So in this case, the students, John Andrew Ferry, Hebe Garate, Julian Fernandez, and Peter Sanjay, analyzed Knoxville and Abando, and what's relevant for this is that they went down from the city. This is the main innovation. They went down from the city, which is that most global indicators measure, to the scale of the neighborhood. So they did the analysis particularized to two of the neighborhoods. So they were looking at intergenerational patterns, human development, social interaction, life's priority needs and services, proximity, which is delivering service needs in the model of the 15-minute city, which I'm sure you all know, and city topology. So how does the form of the city impact on the above indicator? So they were looking at the fractal city, how the city development can adapt to changing networks, and what is the access to service needs according to the shape. They established indicators. It's fair to say that our final master projects have a scope and they have a duration, so they had to work with a limited number of indicators. And the final outcome, again, it's a platform of visualization, which helps for quick decision making via these clever maps that analyze the different indicators. For example, in here we are talking about the proximity to health clinics, which is much better in the Spanish compact city of Bilbao, and particularly this neighborhood, which is a centrally located neighborhood. In the other hand, Pittsburgh is a suburban neighborhood, and therefore you can see that the maps look totally different. Likewise can happen with grocery stores, a higher density in the Bilbao neighborhood against the Pittsburgh neighborhood, and proximity to green infrastructure, which in this case, being suburban, can benefit because they have proximity to green parks. However, Abando in Bilbao, which is also compact city, very centrally located, has proximity to many public realm areas. And finally, as a conclusion, and I'm sorry because I know it extended 10 minutes more than promised, but I was eager to share all this material in this masterclass. The conclusion is that there are many disciplines involved in smart city management. This is an analysis of the Spanish government that I'm going to translate very quickly. They were talking about what are the key professionals in the built environment, urbanism, and sustainable mobility. And I'd say that from the physical infrastructure, we can have urban planners, architects, landscapers, experts in ecology, biodiversity, etc. While in the more tech management side, we can have governance, of course, IT consultants, technology professionals, and of course, transport planners, mobility experts, etc., among other practitioners that also can come in place. Applicable technologies that we can have to foster urban intelligence, among others, I just wanted to give these 4 examples. So we can have artificial intelligence for climate adaptation. We can build predictive models and machine learning to anticipate how will the city behave to climate hazards and other impacts. We can have drones or unmanned aerial vehicles to capture data in large geographical areas and how that can impact in the city. We can build Internet of Things with connectivity and data-driven management via sensors, big data, and then connected to dashboards that can be operated by city officers. And we can have advanced computing for climate adaptation, city information modeling, and digital twins, including augmented and mixed reality for case simulation and scenario planning, as I was explaining previously. The conclusion is that we need to establish a relationship between the physical and the digital dimension of the city, as we can see in this section, but without forgetting that the happy and successful city is that integrates technology within built and regreened or renaturalized built environments in which people and biodiversity can coexist together with the use of technology as a tool and not as a means in itself. Thank you very much.
Thank you, Guillermo. Let me keep share my screen again.
Sure.
Just we are a bit out of time, and I will let some minutes to our audience let some questions if they want. I would like to ask you one thing, Guile.
Yep.
You already answered one question that I got in
Okay.
your conclusion, so I got another
Okay.
answer now. Is
Perfect.
in your view, what will cities look like in 10 years if we effectively harness urban intelligence to combat climate change? In your view?
Well, I think it's a combination between between my last image and my image before. Okay, meaning that um, look like means what we see. Okay, so there are many things that we don't see, which is all the digital. But I would advocate for the final image of how cities could look like because, for example, the last image I showed is a street in Barcelona that was recently transformed, but many cities not yet have that transformations.
Yeah.
So in order to be net zero and with all the ambitious objectives that we have, in my opinions, cities should look like that. And then, let's say behind the scenes or in the backstage, we should have all the technologies in an office and with a dashboard in which most of the citizens won't see that as again, but it will be for management, for efficiently management all the challenges that we have.
Perfect, Gile. Thank you so much. So I think we can finish now the session because we only got 3 minutes. Thank you so much, Guillermo, for sharing your expertise and inspiring us today. Thank you, Guilherme, for all. And a big thank you for you all for joining us today. I hope to see you in the next event. And thank you, take care, and goodbye.
Thanks everyone. Just to say, I'm reading the chat as well, so much appreciated your comments, and thanks Thaisa, thanks Tigurat, and thanks everyone for attending today.
Thank you. See you.
See you.
Bye.
Bye.